There we go. Nice. Okay. So let's have a look at a few problems here. This is the culmination of the unit. The test coming up next week. I'll put up a review. Here's what you could expect. It's going to cover be a little part on solving by isolating, where you get complex solutions with imaginary parts. Right? No big deal. You're going to do that on these anyway, right? There's going to be some complex number stuff, but that's easy, right? Adding, subtracting, multiplying complex numbers, no big deal. Finding the modulus of a complex number, square root of a squared plus b squared, right? Being able to recognize what a complex number looks like when it's wrapped in the complex plane, easy. And then this stuff. This is probably the culmination is solving by completing the square. Right? So let's look at 3 examples where we're going to go through and solve for x. Now keep in mind, on this assignment, everything is going to be solved by completing the square, right? But think about this in a larger context, because the more important test, which is not the one we're taking next week, but kind of the test after that, is going to be the culmination of everything we've done with quadratics. And what that's really going to do primarily is you're going to have to pick the best method for solving a quadratic equation and then use it. So there'll be some questions on that test that will be things just like simply I'll give you an equation to solve, and you have to pick what's the best way to do it. And that's the right answer is by picking the best, easiest way, right? So not everything is going to be done by one method. We were thinking of this in terms of an overall kind of a strategic approach, which is good in math because that's where math goes in the future. That's what calculus mostly is just being strategic, right? So with a problem like this, what's the easiest way to solve a quadratic equation? What do we always look for first? What do you think? What kind do you like to do the best? What are the easiest ones to do for the quadratic equations? You don't like doing any of them? Oh. Well, wouldn't it be, and we haven't done this in a while, but wouldn't it be the easiest way would probably be the kind where you can just isolate x, right? Oh, yeah. Those are no big deal. You just work backwards and you strip away everything on the side with an x until the x is by itself, and then you're done, right? But that only works if there's a single x, so no go here, right? So strike one. If we can, we like to factor, right? So on this one, I mean, we could, if we wanted to, we could write this in standard form. And we should, just to see if there's some trickery we can do to make this easier. We'd like to factor it. Do the magic numbers work here?
Absolutely not.
No, they do not. There are no numbers that multiply to -2 and add to 7, so strike 2, right? So then our goal is we just want to, using the simplest method possible, we just want to get this into the form x squared plus bx equals some number. Well, that's pretty easy here. In fact, it was already in that form, wasn't it? Right, so what do? What's the one thing we have to do?
Add 2.
Yeah, just add 2 to both sides, and then we get it in the form we want it in. The x squared has a coefficient of 1, right? Plus 7x equals 2. Okay, so that's the end of part 1, right? Part 2 is we're just going to complete the square, right? And that's the stuff we've been practicing, so you're getting pretty good at that. So can you tell me on the left side, shut that off, huh? We're going to fill in a bunch of blanks, aren't we? Right? We're going to fill in, we're going to have a blank there, we're going to have blanks there and there, right? I got to treat both sides equally and add the same number to both sides. And then I've got a blank right there I've got to fill in. What's the order? What do I do first? Yellow, green, or blue? Yellow, for sure. Yeah. So we already know, I mean, really all we're trying to do, if you think about this big picture, don't just get caught up in the individual steps. Kind of think about what we're doing overall. What's our strategy? Well, we're trying to take this equation up here that has multiple x terms, and we want to turn it into the kind that only has a single x, right? which we're going to do by creating this perfect square where we have x plus some number squared, right? Okay, so we just want to get to here, and then once I've plugged in the yellow number and the blue number, I can just isolate x very easily by just square rooting and then moving that number to the other side by adding or subtracting, right? Easy. But to get there, well, we already know what that number is going to be. What's it going to be? 7/2. Yeah, half of b, right? But to be able to use this, this row here, to get there, we have to know what goes in the blue box. But to know what goes in the blue box, we've got to know what number we added to both sides to create the perfect square, right? So what's the second box we fill in? What color?
Blue.
No.
Oh, green.
Green. Yeah, we got to know green first, because then we'll add these up to get the blue, right? So then, once we know what this number is, we'll move up to green, right? So what number are we adding to both sides then?
7/2.
Squared.
Square,
Oh.
right? So that's going to give us, we just square the top and square the bottom. So 49/4, right? And then now finally, we got to add those up and figure out what the number on the right side is. So what am I going to multiply top and bottom by to get a common denominator?
4.
4,
Oh.
right? And so that's going to give us on this side, I'm going to get 8/4 plus 49/4 is what?
57.
57/4, good. Okay, so we got it, right? So now we completed the square, right? Now all we've got to do, once we complete the square, let me rewrite that. Right, so now we're just going to take this equation and isolate x. Well, what are the two steps to isolate x? Square root, and then subtract 7/2, 7/2, good. So first of all, if we square root both sides, before we do anything else, what do we have to include?
Plus or minus.
Plus or minus, yeah, and I'm gonna write that down immediately, otherwise I might forget it, right? So the square root cancels the square. Now what about the right side? If I square root a fraction, what do I do?
You just can't do it.
What can I do? I mean, I try to reduce the fraction.
And then you square root the bottom.
Yeah, good, I'm just gonna break it up into the square root of the top and square root of the bottom. If I could simplify that fraction, I would, that'd make things easier, but I can't. 57/4 is, right, they're reduced. It's already reduced. There is no common factor that I can divide top and bottom by, right? So I just end up with square root of 57 over square root of 4. Square root of 4 is 2, good, and
Square root of 57.
square root of 57 I'm just stuck with, aren't I?
Yeah.
57, if I factor it, it just factors into 3 times 19, and those are both prime, right? So there's no couples, everything stays in. So that was x plus 7/2, last step.
Minus 7.
There you go, and that goes in front of the plus or minus, right? So we get x equals negative 7/2 plus or minus square root of 57/2, and we're done, right? I get one for the plus and one for the minus. Those are my two answers that I didn't put separated by a comma, right in the middle. Okay? Questions on that? Yes?
Why do you add the 49/4 to the other side? Why don't you?
Oh, up here?
Yeah.
Okay, because what we started off with was we didn't have anything there, right? All we had was the 2 on the right side. Okay, but this is an equation. So whatever I do to one side, I have to do to the other side. Now think on the left side. We need the 49/4 because adding that 49/4 creates what we call a perfect square trinomial that's gonna factor into a perfect square, right? So in order to get x plus 7/2 quantity squared, we have to include that 49/4 up there on the left side, right? But if I'm gonna add that to the left side, I have to add it to the right side too, because it's an equation. Okay, does that make sense? Okay? Any other questions on that? Okay, let's go through another one. Just a little bit harder, but not much, really. So what do we do?
Oh my gosh, not
This is
much.
lightweight.
Yeah, it looks terrible, but it's no big deal.
This is lightweight. I'd add 14 because I don't want to have to deal with a negative.
Okay, right, but you're on the right track, but we really don't care about, the only term we really care about being positive is which one?
Boo. Look on the other side.
Subtract 4x.
Oh, okay, so it's, but and really, all we care about, we'll worry about the other terms later, but we want to have A be positive, right? We want a positive number of x squares, for sure. So that dictates which side we're going to move stuff to, left or right?
Right.
Left.
Left, because 6x squared is bigger than 4x squared, right? So you're gonna move everything to the side with a larger number of x squareds, because we got to end up with a positive number of x squareds, right? Okay, so everything's gonna go left. So I'm gonna subtract 4x squared from both sides, leaving me how many x squareds? Okay, so I get 2x squared. I'm gonna subtract 4x, because I gotta move it over here, so that leaves me with how
Plus
many?
10x
And then I'm gonna add 14.
plus 20.
Okay, good. So that's good, right? That helps. You get everything on one side, we put it in standard form. Now, let's see, we want to make this as easy as we can. Is there a common factor on the left side that I could divide it both? Let me say this carefully. Can I divide both sides by something to make the left side easier? Two, right? And there's two ways we can show this. We could factor it out as a greatest common factor, which is fine. We can factor out a 2,
You were just.
which leaves us with what?
20x.
What?
Plus.
If I undistribute a 2, what am I left with?
X squared
X squared plus
5x
5x plus 10. Okay, does everybody see that? Okay. And then on the right side, I've just got my 0. Okay, well this is, because we've got an equation that's set equal to 0, that's important. I can divide the 2 away, can't I? I can divide both sides by 2, and 0 divided by anything is
0.
0. Good. So we can do this, right? We could just say, we could just cancel those and end up with, on the left side, x squared plus 5x plus 10 equals 0, right? There's another way to do that. This is the way I do it a little differently. What I would do instead is I would just divide I would recognize that 2 is the greatest common factor, and we're just going to divide both sides by that anyway. So let's just start off by dividing each side by 2, right? But when I divide the left side by 2, I'm dividing each term by 2, right? So do you see that the left side, if I do that, I'm just going to get this result? Okay, and on the right side, I'm just going to get a 0, okay? Take your pick. I think in the solutions I created, I do this. Right? But that's the same thing, and it maybe is a little bit cleaner in a way. It's fewer steps at least, right? Take your pick. I don't care. Last step then, if we want to get this in the form x squared plus bx equals a number?
Minus 10.
Minus 10. Okay, good. So, and then we're there, aren't we? So we've got x squared plus 5x equals negative 10. Okay? So we made it. Now complete the square, right? Okay, so completing this square, let's see. I know I'm going to get something that looks like that. So what's the perfect square that I'm going to end up with based on the value of b? X. What? What's the number that goes with x?
1.
No.
Oh, wait, no, we're doing
5 over 2, yeah, right? It's always based on the value of b. It's half of b. So we get plus 5/2, which means what number am I having to add to that side to create that perfect square? Which is,
25 over 4.
okay, good, which means I've got to add 25 over 4 to both sides, right? Okay, which gives me what? So I get on this side, I'm getting my x plus 5/2 quantity squared. Up here, though, I want to be able to add up those fractions to see what's left over. What do I get? I'm going to multiply this one by 4 over 4, right? So I get 25/4 minus 40/4. There's another way to write that. I could write them separately as 25/4 minus 40/4, but I've got my common denominator. I built a common denominator of 4. So I could just put a 4 on the bottom of everything, right? Either way, take your pick. What do I end up with on the top?
15 over 4.
Negative.
No,
Negative 15 over 4, right? Okay. So we got it. We completed the square, and now all we have to do is solve by isolating x, right? Okay, so what do? What's the first thing I do? Square root. Okay, so I get x plus 5/2 equals square rooting both sides. What do I do?
Positive.
Plus or minus, good. And now what about this? I'm going to take the square root of negative 15/4. So the square root of a negative means what?
Something high.
We're going to get 9. Yeah, right? Everybody agree? So we're going to get that part right there tells us we're going to get a 9. Right? What am I left with? Well, the square root of 15 over the square root of 4, right?
You have to square them both.
So the square root of 15 we're stuck with, but the square root of 4 is 2. Okay, so everybody agrees that's what I end up with on this side, right? Okay, what else am I going to do to get that x by itself?
Minus.
And that's going to go in front of the plus or minus. So there's my answer, right? Negative 5/2 plus square root of 15 over 2 times I, or minus. Okay. Make sense? Okay, one more. How about one like this?
Do you enjoy math?
Yeah.
Sorry, right now, I feel like I'm in the Arctic Ocean, and this morning I just flew to the Hawaiian Islands. It is freezing in here.
It is, I know, it is, and I can't, oh, now it says it's off.
Yeah, no wonder, I'm freezing.
But it doesn't.
It's not all about you, Aspen.
Like if I hit the
But
temperature
it's
thing,
not cold.
all it does
We
is
are all
say
dressed in
60.
white here, and I feel like I'm at the Oregon coast. I'm freezing.
Maybe it's working and stuff. Something happened, for the first time ever. Okay, there we go. That'll warm it up, Aspen.
Thanks.
Okay,
I'll
So-
so, like this until it gets warm.
there you go. So first thing I'm gonna do is what? Okay, add like terms. Which side am I gonna push everything to, left or right? Left. Okay, how many x squares do I end up with?
1. Oh, never mind. You have to add it. Yep, 3x.
3x squared, okay, good. There's no, I already have a negative 18x, if I add 13. Okay, can I make that easier? Could I divide both sides by anything? 3. But 3 doesn't go into 28, right? Okay, so I can't just divide both sides and have done with it, right?
Mm-mm.
But I am going to end up dividing for a different reason now, right? So there is no greatest common factor I can just get rid of that makes everything easy. But I still need to get it into this form, x squared plus bx equals p, right? So what are the two things I've got to do to turn this into that?
Well, first you gotta get rid of that 28.
Okay, so I'm gonna subtract the 28. Good, I've gotta get the number on the other side. Good. So, we get 3x squared minus 18x equals negative 28. Okay, what else?
Add the 18x.
Square it.
No, 'cause I need to have an x squared, I need an x squared and an x on the left, right? But
Oh, divided by 3.
divided by 3, because I need to have a 1 in front of the x squared. So I'm gonna divide each side through by 3. So we do end up dividing by 3, don't
Oh, so then it's x squared
Aha.
negative 6x.
Okay, so when I divide by 3, I'm dividing both terms by 3, right? So that's gonna give me x squared, and if I wanna show this, really what I've got is 3x squared over 3 minus 18x over 3 equals negative 28 thirds. You don't have to show this step, but I just wanna reinforce that you're dividing each term separately by 3, right? So then what do we end up with? Well, the 3's cancel, so I get x squared.
Negative
18
6x.
over 3, good, is negative 6x, and over here I am stuck with negative 28 thirds, right? Okay, so now we completed part A. We got it in the right form, now we've got to complete the square, right? So the left side is going to become what? Which is 3. Okay, so what am I going to write in here then? X minus 3 squared
What the heck?
equals, well, we don't know yet, right? Because we need to figure out what number we're adding to both sides. What is that?
9.
9. Negative 3 squared is 9. Right, so we're going to add fractions up over here. So what do I need to multiply this one by? Right, so that's going to give me negative...
Why'd you just get that 3?
Say it again?
Why'd you just get that 3? Where'd that come from?
Because I started off adding negative 28 thirds plus 9. So when I add 9 is the same as 9 over 1, right?
Negative 6 over 2 is 3.
Yeah, I think it's.
Oh,
back to
where did
back.
I get this one to begin with? Oh, I got you. Yeah, right here, right? We know that if b is negative 6, then I've got to take,
that gets rid of the x.
doesn't get rid of the x.
Negative
We
6.
just know that if I'm gonna, like once we've done, put the 9 there, if I were to factor this, what are the magic numbers that multiply to positive 9 and add to negative 6? Negative 3 and negative 3, right? See, we created a perfect square then, right? Because the magic number is going to be the same thing. That's our whole goal. So we can write it as something squared,
Okay.
right? In order to do that, though, it's always going to be the same pattern. The number that goes with x is always half of b, but the constant that we need to make this thing factor properly is that number squared.
All right, that makes sense.
Okay, so then over here, when I add these up, that's gonna give me negative 28 thirds plus 27 thirds is negative 1/3, right? Good. So if we square root both sides, now we're just gonna isolate x. That's no big deal. Right, to isolate x, we'll just square root. So I get x minus 3 equals, you tell me. But if I square root both sides to get rid of the square, what do I need? So I'm square rooting.
Somebody say something.
You gotta tell me what to write.
Square root of 1, 3.
Of negative 1/3, okay. Before I put the square root,
Plus or minus.
plus or minus, good. Plus or minus, square root of negative 1/3, right? So what's that equal then on the right side? I've got my plus or minus, what's the negative become? An I, good. Times the square root of 1/3. So we can break that into the square root of 1 over the square root of 3. So what's the square root of 1?
Which is 1.
and I get a square root of 3 on the bottom, right? Okay, so that's a little bit of a problem. We can't have a stranded radical on the bottom, right? So let's make a note about that. So we've got,
You must not be very rad if you strand your body.
Make fun of him.
Great.
What are you looking at?
so we can't have a stranded radical in the denominator, right? So what's our solution to that? How do we fix that problem? What do we always do? I can't square it because I've got to treat, okay, I can't square it because I'd be changing something.
Do you
right?
tackle the reciprocal?
Well, almost. Now, I want you to, rather than just going through the step, let's think about why this is the step. What do we do, like if we're going to, well, here's an example. We already did this once. When we added the fractions up, okay, when I'm adding negative 28/3 to positive 9, I'm going to get an answer, and I can't change the answer. It's got to be the same value, but I just want to write it in a form that makes sense, right? Negative 28/3 plus 9 is not a convenient way to write that value, but if I put it in, here's my point. If I were to put this into a calculator, negative 28/3 plus 9, I would get some decimal answer, right? The decimal answer can't change, but I need to be able to write this in a way that's more convenient, which in this case is negative 1/3. How do I do that? I'm going to change 9 over 1 to become 27 over 3. But isn't 9 over 1 exactly equal to 27 over 3? Agreed? Same decimal values. But in order to change what it looks like, I'm going to multiply by 3 over 3. Okay, that's tricky, right? But did I actually change anything? What is 3 over 3 equal to? 1. Anytime I have the same number in the top and the bottom of a fraction, it's always equal to 1. If I multiply something by 1, do I change its value?
No.
No, because 1 is the identity number for multiplication. Going clear back to algebra 1, right? So what I can always do in algebra, I can always multiply something by 1 and not change its value, so that's always fair game, right? When I'm dealing with an equation, I can multiply any part by 1, and I'm okay. I haven't changed its value, just the way it looks. Or I could add 0, which we don't do very often, but we could do that also, right? So what I've got to do here then is I can't change the value of this fraction. It's still got to equal the same decimal number, but I want to make it look differently. So I have to multiply by the same thing on the top and the bottom to multiply by 1. Does that make sense? Okay. And that's really important in algebra. So what's that going to be then? Say it again? Cam, what were you thinking?
3 over 1.
Well, it's, no, because 3 over 1 would be multiplying it by something other than 1, and that's not fair. Then I'm changing the value of that number, which I can't do. Right? But think about, the problem is on the bottom, isn't it?
Yes.
Right? So I need to multiply the bottom by whatever I need to multiply it by to get rid of the radical. And then I'll just do the same thing to the top. How can I undo a square root of 3? By multiplying it by, no. 1 times the square root of 3 is just the square root of 3. Square root of 3. Now here's our puzzle that we're trying to solve. Right? We've got square root of 3 times what equals something that's not a square root? There's two ways you could think about this. How do you undo a square root? You square it, right? Okay, but we can't just square it. You got to multiply by something that's the same thing as squaring it. Well, square root of 3 times square root of 3 would be squaring it, wouldn't it? When you multiply something by itself, isn't that the same as squaring it? 7 times 7 would be 7 squared. Pi times pi would be pi squared. Square root of 3 times square root of 3 would be square root of 3 squared, right? So if we multiply by square root of 3, then isn't that the same thing as the square root of 3 squared? Right? Which is also the square root of 9. What's the square root of 9?
81.
3, right?
Oh, wait.
So we're going to multiply top and bottom by square root of 3. Okay, and you see why we're doing that? Because then on the bottom, what are we getting? What's the bottom gonna become?
3.
3. And the top is gonna be 1 times the square root of 3. So I get a square root on the top, but that's okay. We can have a radical on the top, we just can't have a radical on the bottom of the fraction, right? And so then we've got our I. Now, what do you think is going to happen if I put in 1 over the square root of 3 in a calculator, or square root of 3 over 3? You think the decimals are going to be the same?
I do not.
Do you think so? They have to be, don't they? Because I just multiplied by 1, right? Here, I'll prove it. Seeing is believing, right?
Right. Do you believe in magic?
Math can be kind of magical at times. Yeah, I do. I believe in math.
Do you have to download that on like some sort of?
Yeah. So if I do 1 divided by the square root of 3, where's square root? Right there. Look what I get. 1 divided by the square root of 3 is 0.57, blah, 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 right? Now if I do square root of 3 divided by 3, what do you know? Same thing, right? So they equal, they have to, because I just multiplied by 1, so I didn't change anything. I just changed the way it looks, so I don't have a square root on the bottom anymore, right? That's all I did, okay? So now we got rid of the radical, so that's what's on the right side. And really all we did here was we took this plus or minus the square root of negative 1/3, and after we simplified all the radicals, we get this result, right? That's our result, okay? On the other side, we've just got our x minus 3. So what's our last step? Add 3, right? So we end up with x equals 3 plus or minus square root of 3 over 3 times I, right? That's it. Okay, make sense?
Sure.
Okay? And it seems like a lot, but now you just got to go practice it a little bit so you can kind of cement it in your brains.
Good this practice.
All right, work on the new assignment.